Hey, you guys, welcome back. Today we're going to go over two-step equations. Before we do that, though, fact number 32 about me. I put this picture over here on this set of questions. Some of you might recognize these guys immediately. This is Fred and George Weasley. They're a couple characters from the Harry Potter movies, and as you know, if you're in this class, I'm a really big Harry Potter fan. And this is a set of twins from the Harry Potter movies, and they're two of my favorite characters. The reason I put this picture up here is because I'm a twin. I have a twin brother. His name is Kevin. He lives back up in Chattanooga, where I'm from. We are not identical. We are fraternal twins. We don't look anything alike. Actually, he has red hair. So, kind of funnily enough, he looks more like these two guys than he looks like me. For most of our lives, we were very, very different. And you hear that a lot about twins. Growing up, we had no similar interests. We didn't like the same movies. We didn't have the same friends. We had nothing in common. And then once we turned maybe 21 or 22, we kind of started to see that we actually have the same sense of humor. We have an interest in golf, and we have the same taste in movies and TV shows a lot of the time. So we've kind of become a lot more similar as we got older. For the longest time, we weren't close, and now we are pretty close. And oh, some of you guys are twins in class, and some of you guys have the same class, which is crazy. So I think I have two classes with two sets of twins in here, which is really cool. Me and my brother, we didn't have the same class after first grade. We had the same class in kindergarten and in first grade. And after that, we were both like, never again. But that's mostly because we had nothing in common. We were just so different from each other. We didn't want to hang out with each other. Now, however, I love getting to hang out with him. So I love getting to go back home and get to see him. It's great. So, anyway, let's get back to the math. We're going to do two-step equations today. Let me get the pen going. There we go. Two-step equations are a lot like one-step equations, except there's one more step involved we have to do first. So, whenever we do this, the main thing we're going to hear is this phrase right here, the inverse operation. All right? So, if I have addition in my problem, I'm going to do the inverse and use subtraction. If I have subtraction in my problem, I'm going to do the inverse, the opposite, and use addition. If I have multiplication going on in my problem, I'm going to do the opposite and use division. And if I have division going on in my problem, I'm going to do the opposite and use multiplication. All right? All I'm going to do is the inverse operation over and over and over again, essentially. The other thing that we need to focus on is that step one in all these problems, it's going to be the same. Step one in every single one of these problems, that's an E right there. Step one is to eliminate the constant. All right? Whatever number is by itself, not involved with the variable, I'm going to get rid of that number first. Okay, let's look at this one. 3x plus 2 equals 11. Now, a constant is any number that is by itself without a variable. It's constantly alone. There's a 2 right here, a constant, an 11 right here. Now, you might say these are both constants. The constant I'm talking about is the one on the side of the equal sign with the variable. That'd be this one. This is the side of the equal sign with the variable, okay? So all I'm talking about is this 2. I'm not going to do anything with that 11, all right? All I'm going to mess with is this side of the equation because it has the side with the variable. So let me give that an erase. And let's go through and solve this. Whenever we solve equations, all we're really talking about is trying to find x equals what? We're trying to find what x equals, okay? The way we're going to do that is getting rid of all the numbers and operations that are going on around the x. So step number one, eliminate the constant. That's this plus 2. The way I eliminate anything is by doing the inverse operation. So instead of plus 2, I'm going to get rid of it by subtracting 2. Cancel that out. I'm going to do the same thing over here, subtract 2. So now I'm left with 3x equals 11 minus 2. That gives me 9. So now I have 3x equals 9. This is just a one-step equation. So this 3 and the x, it is hard to see, but let me rewrite it. I'm sorry. One second. Let me rewrite it a little larger so we can see a little better. This is 3x equals 9. All right? I have to get rid of this 3 with the x. Now, between the 3 and the x, we don't see any operation. There's no plus sign, no subtraction sign, no multiplication sign, or division sign. When we don't see an operation, we know that multiplication is going on in between there, okay? So right now, this x is being multiplied by 3. To get rid of being multiplied by 3, I'm going to divide by 3. I'll do the same over here. because I have to do it on both sides of the equal sign. This cancels out. So now I'm left with x all by itself, which is exactly what I want. Now on the other side, I have 9 divided by 3, which is 3. So x is equal to 3. Let's look at the next one. 2y minus 8 equals negative 6. So step number 1, eliminate the constant. And remember, we're only talking about the side of the equation with the variable in it. So my constant right here is this 8. So right now I have minus 8. To get rid of subtracting 8, I'm going to do the opposite and add 8. That cancels out. I'll add 8 on the other side of the equation as well. 2y, I bring it down, is equal to negative 6 plus 8, that's positive 2. So now I have to get rid of this 2 with the y. Remember, if we don't see an operation going on, we know it's multiplication, all right? So to get rid of multiplying by 2, I'm going to divide by 2. That cancels out. I'll divide by 2 over here, and I'm left with y equals 2 divided by 2. That gives me 1. Perfect. Let's look at number 3. Negative 5a plus 10 equals 20. So once again, step 1, eliminate the constant. The constant here is this plus 10. So the way I get rid of plus 10 is by doing the opposite. I'm going to subtract 10. That cancels out to 0. I'll subtract 10 on the other side as well. And now I'm left with negative 5a is equal to 20 minus 10. That just gives me 10. So now I have to get rid of this negative 5 that is with the a right now. Remember, if we don't see an operation, we know it's multiplication. So to get rid of multiplying by negative 5, I'm going to divide by negative 5. That cancels out. I'll divide by negative 5 over here. Remember, whatever we do on one side of the equal sign, we have to do on the other. And I'm left with a equals 10 divided by negative 5. That just gives me negative 2. So a is equal to negative 2. Let's look at this one over here. Hang on a second. Wait, did I make a mistake up here? Hang on. One second. No, that's perfect. Yep, a is equal to negative 2. All right, let's look at the next one. Negative 2 minus 6x equals negative 20. Oh, wait, look. The first term doesn't have a variable in it. It's the constant. That's okay, though. That happens. That's just fine. Whatever order it is, you can still solve it all the same. Step number 1, eliminate the constant. This has a variable in it. I'm not going to mess with this yet. This negative 2, though, that's a constant. It's a number by itself, no variable. So to get rid of a negative 2 and cancel it out to make it 0, I'm going to add 2. All right? That cancels out. I'll add 2 over here. So I'm left with negative 6x equals negative 20 plus 2. That gives me negative 18. So now I have negative 6x. Remember, there's no operation. I know it's multiplication. So to get rid of multiplying by negative 6, I'm going to do the opposite. I'm going to divide by negative 6. That cancels out. I'm going to divide by negative 6 over here. Whatever I do on the left side, I have to do the exact same thing on the right side. X is equal to negative 18 divided by negative 6. That gives me positive 3. Now on this one, if you had wanted to rearrange it so that the variable is first, you totally could, but it can be a little tricky to do that and keep your signs straight, okay? The way I always do it to make sure my signs are right is I always change this to addition and change the sign of the following number. Remember, that's the commutative property where I can move around the terms as long as they're being added and I get the same answer, okay? If it's subtraction, I can't move them because the signs, they can be a little iffy and you might make a mistake that way. So I could rewrite this as negative 6x plus negative 2 equals negative 20. I would do the same exact steps. I would add 2 to get rid of that negative 2. I'd add 2 over here. Negative 6x is equal to negative 18. And eventually I'd solve for x equals 3, okay? One thing you might be a little confused about, this is negative 6x plus negative 2, the way I rewrote it. Now, you probably won't see it like that if you see a quiz or a test or something because we don't typically put pluses and negative signs together. So you would probably see it like this. Negative 6x plus 2. Negative 6x minus 2 equals negative 20. All right? Again, the same process. I'd add 2 to both sides. I'd still end up with the same work and the same answer, okay? That is just showing you that you could do that if you wanted to, but again, you don't have to. All right, you can leave it exactly as is as long as you get rid of the constant first to make it cancel out, and then finish out the equation. All right, so let's scroll down. I'm going to give that an erase so I can scroll down. There we go. Let's work on number 5. Number 5 says negative x minus 5 equals negative 10. So negative x minus 5 equals negative 10. I'm going to get rid of the constant first. I'll add 5 to both sides. And I'm left with, that cancels out, negative x equals negative 5. Now some of you might circle this and think, oh good, that's my answer. This is not. This is a negative x. We never solve for negative x. We want positive x. So the way we do this is I have to remember that even though there's no coefficient in front of that x, there's a 1 there. So look, this is a negative 1 in front of that x. I have to get rid of that negative 1. The way I do that is by dividing by negative 1, because I'm just doing the opposite operation. Divide this by negative 1, and I'm left with x is equal to positive 5. Let's look at this one. X over negative 1. Oh, this is a little different. Minus 6 equals negative 3. But you know what? The steps are still the same. Step 1, get rid of the constant. Minus 6, I'll get rid of that by adding 6 to both sides. That cancels out. I'm left with x over negative 1 equals negative 3 plus 6. That's just 3. So this is x divided by negative 1. Kids always get a little intimidated and nervous when they see a fraction looking like this. But all this is telling us is that this is division. So instead of dividing by negative 1, I'm going to do the opposite. I'm going to multiply by negative 1. That'll cancel that out. I'll multiply by negative 1 over here as well. X is equal to 3 times negative 1. That's negative 3. Let's look at the next one. X over 3 plus 8 equals 10. Again, step number 1, eliminate the constant. Plus 8, I'll get rid of that by subtracting 8. I have to do it on both sides of the equal sign. That cancels out, and I'm left with x over 3 equals 10 minus 8. That's 2. And remember, this is x divided by 3. That's all that is doing right there. So instead of dividing by 3, I'm going to cancel it out by multiplying by 3, by doing the opposite. I'll multiply both sides by 3. And x is equal to 2 times 3. That's 6. Let's look at the next one. Negative 4 plus y over 7 equals 2. Now this is in an opposite order, but again, it doesn't matter. I get rid of the constant first. The way I get rid of the negative 4 is by adding 4, because that cancels out to 0. I'll add 4 over here. So I'm left with y over 7 equals 2 plus 4. That gives me 6. So now looking at this is y divided by 7. That's all that fraction bar is telling me. So instead of dividing by 7, I'm going to get rid of that 7 by multiplying. So I'm just going to do the opposite operation. Those 7s cancel out. I'll multiply by 7 over here as well. And y is equal to 6 times 7. That's 42. Let's look at this one. Look at this one. Look, the variable is on the right side of the equation. Look, it's over here instead of on this side. That's okay. It's an equal sign, so both sides of the equation are the same. I'm still going to do all the work the exact same. I'm going to get rid of the constant first, and the constant that's on the side of the equation with the variable. So I have this minus 6 over here. I'm going to add 6. That cancels out. I'll add 6 over here as well, and I get negative 10 plus 6. That gives me negative 4 equals a over negative 5. This is a divided by negative 5. To get rid of that, I'm going to multiply by negative 5 on both sides. That cancels out. Multiply by negative 5. I'm left with 20 equals a. Just fine. Or you could switch it around to a equals 20. You could also switch around the entire equation if you wanted to, but you don't have to. It's not necessary. Let's look at this last one. Step number 1, get rid of the constant. This minus 3, I'll get rid of it by adding 3. That cancels out to 0. I'll add 3 on the other side. So now I'm left with x over negative 2 equals negative 9 plus 3. That gives me negative 6. So now I have to get rid of this dividing by negative 2. Instead of dividing by negative 2, I'm going to multiply by negative 2. And that'll cancel out. I'll multiply by negative 2 over here as well. And now I'm left with x is equal to negative 6 times negative 2. That gives me 12. Perfect. All right, you guys, thanks for sticking around for the whole video. And I will see you guys in class tomorrow.